Hi everybody, welcome to the first video in a series at looking at what we call indices. So before we begin, we'll have to look at what exactly an index is. So if we take some number and we put it to a certain power, so in this case I've got x to the a, these two parts represent two different things. So our x is what we call the base number or the base value, and our a is the index or the index itself. So what it basically means is we're taking the base and multiplying it by the number that the index represents. But first of all, at National 5 level, we look at certain rules and certain things that we need to do with indices. So we're first going to be looking at the first rule and the second rule. So the first rule is basically talking about how we multiply indices. So if we're multiplying two indices together that have the same base, that means that in the end, all we will be doing is adding the powers together. So as long as they have the same base, we can add them together. If they don't have the same base, then we can't add them together. We can't add the powers together because they're at a different base. So a couple of quick examples of this. So let's just say we have x to the 4 times by x to the 3. That basically just means x to the power of 4 plus 3. So we'd get x to the 7. Now one thing you might come across an example where you have x times x to the 9. Now although you can't see it here, there is an actual index here, and it's an index of 1. So what this just means is we have x to the power of 1 add 9, which gives us x to the 10. Another example we might come across is we might have a number in front of our base number. So we could have the likes of 2x to the 3 times by 4x to the 8. Now, when we're solving index problems like this, we need to take into account that we're multiplying the two numbers in the front. So we'll be doing the 2 times the 4, as well as the 3 add the 8 for our index power. And that's just going to give us 8x to the power of 11. So we've multiplied the 2 and the 4 together, and we've added our indexes together. So that's the first rule. The second rule is looking at the opposite. What if we're dividing? So say if we get x to the a divided by x to the b, well, logically thinking, timesing and dividing are opposites, so the opposites of adding is going to be subtracting. So we just subtract our indexes from one another. And just to go through some examples, we have x to the 7 divided by x to the 4. That's the same as saying x to the 7 take away 4, which leaves us x to the 3. Now, you may not always see them in this kind of form where we have a straight dividing sign. You may also see them over one another, and it still just means the same. So we've got x to the 10 divided by x to the 2, so that's going to be x to the 10 subtract 2, which gives us x to the 8. Now, as before, when we had two constant numbers with our multiplying in our first rule, we do the same thing with the dividing. So say for example we had 9y to the 7 divided by 3y to the 2. We're going to be dividing the first lot. So 9 divided by 3 gives us 3. And we've got y to the 7, subtract 2. So our answer is 3y to the 5. Similarly, if it's in this form as a fraction, say, for example, we had 12x to the 15 over 6x to the 7. Well, we do the dividing first for our whole numbers, so 12 divided by 6, which gives us 2, and we've got x to the 15, subtract 7, which gives us 2x to the 8. So, our two rules for indices, multiplying and dividing. When we multiply them, we add our index powers. If we've got two constant numbers in front of them, we have to multiply them, but we add our indexes. And with dividing, we subtract them, and we have to do the same and keep an eye on our constant numbers that are in front of our bases.